Number one, how do we find how many yards are in 99 feet? How do we find how many yards are in 99 feet? That.
99 divided by 3.
And that gives us?
33.
Okay. Number two, if we have a half, how many sixths would that be? 3. Number three, $9.80 multiplied by 59. 59.
57,800.
Not quite. Not quite. Eduardo? $578.20. Now, if we would do an estimate on that, $9.80, and we're multiplying by 59. $9.80 is close to how much money? $10. 59 is close to how much? 60. 10 times 60. Well, if we're multiplying by 10, what happens to the decimal point? 1 to the right, making it 600. So our answer should be close to $600. Was your answer close to $600? Okay. Number 4, how do we find the perimeter of that square? Adam?
We add all the sides up.
We can add all the sides up. What else could we do? 4 times 4, because each side measured 4 and all 4 sides were equal. What was the perimeter of that square? Perimeter of that square? And a label? Not square feet? Units. Number 5. We have 51 minutes and we're multiplying it by 3. How many hours and minutes would that be?
10 hours and 50 minutes.
Not quite.
2 hours and 33 minutes.
2 hours and 33 minutes. And how did you get that?
I divided 832 divided by 4, and I got 28.
Where did you get 832 from?
I took 51 times 3,
Mm-hmm.
and got 153.
Mm-hmm.
And then I took 153 minus 60.
And why minus 60?
Because 60 minutes are 1 hour.
Okay, because that equals out 1 hour.
And then I took 60 and then again.
Because?
60 hours.
Uh-huh.
And then I got 32 minutes. And I added up to 2 hours.
Okay. So I gave you 2 hours. And you had 30 minutes. All right. If I do it any other way? If I divide this by 60? How many groups of 60 you had? Okay. Number 6. The point where 2 rays meet is called the vertex. How many of you had false? It was true. It was true. It was true. Number 7. The best estimate for the measure of the angle. How many of you had 40 degrees? 90 degrees? 170 degrees. It is 170 degrees. 40 would barely, well, it'd be up and about like that. About like that. Okay? Number 8. Number 8. What did you get for your difference? Your difference.
16 and 99.
Good. 16 and 99 hundredths. Number 9, you divide 832 by 4. Your quotient is 208. Number 10, what comes next in the pattern? Are both circles alike?
Oh no,
Which one? Okay, so it's an open circle followed by a closed circle. Any questions on those? Yes. Question? No? Okay. Please get your score recorded then. As we take a look at your answers on page 237. To speed things up today, I'll read the answers. Most of you did a nice job of showing me how the decimal point moved using the arrows. Number 2, 33 3/10. Number 3, 23 hundredths, 2 3/10, 23, 230. Number 4, 390, 39, 3 9/10. Number 5, 5, 5/10, 500. Number 6, 9,670, 967, 96 7/10. Number 7, 874, 8,740, 87,400, 874,000. Number 8, 10, 100, 1,000, 10,000. Number 9, 49 32 hundredths, 493 2/10, 4,932, 49,320. Are there any questions on any of those? Number 10. If each square has an area of 6 square feet and spans a total of 1,000 square meters yard, if we're multiplying by 1,000, what happens to the decimal point? Ezra? If we're multiplying by 1,000, what happens to the decimal point, folks? Quick, quick. Quick, quick. Lane. Yep, giving us 6,000 square feet. 6,000 square feet. Number 11. Reasons are selling items at a bake sale. May makes $23.25 selling bread. Ina sells gift baskets, which makes 100 times as much as May. If it's 100 times as much as May, 100 times as much as May, how do we figure out how much May made? How do you figure out how much May made? And how do we figure out now how much Ines made? Adam? And what does that do to this? How can we easily multiply that by 100? Pardon? How many places are we going to do the decimal point? Okay. So she makes $2,325. Okay. Then it goes on to say that Joe sells pies and makes 1/10 what Ines makes. How do we figure out how much Joe makes then? What do we need to do? One to the right if we're multiplying by 1/10? If we're multiplying by 10, we go 1 to the right. If we're multiplying by 1/10, we go 1 to the left. So there's our three amounts. Okay. Questions on that? Anybody? All right, so take a look at number 1 on page 238. If it's 100, where does the decimal point move? It's 882 to start with. It's 1/100th of that. Lane?
8 and 82.
Okay, to the left, making 8 and 82/100ths. And a label would be feet. Number 2, 10 squared times 18 and 72/100ths. We want to know where the decimal point moves to get the correct product. Where does the decimal point move, Lane?
2 places to the right.
Okay. Number 3, we're putting the heights in order from least to greatest. 415 and 138 thousandths. 452 and 18 thousandths. 457 and 2/10ths. 828 and 142 thousandths. Questions on that? You need. Yep. Number 4, Madison's new account balance. She had started out with a $187.56. She deposited money. What does it mean to deposit money? Put it in, so we're going to add it. Then she used her debit card to spend money. If she spends money, what are we going to have to do? Subtract. What's her new account balance?
218 and
Dollars. Oh, dear, you have the wrong balance.
$218.51.
Oh, my goodness, 2 people with wrong balances. You have problems with your accounts, folks. You might end up having a ding on your account. Yes?
$218.65.
Yes, $218.65. 1 penny off could cost you in the long run. Here's the deal. Some accounts, they say you have to have like a minimum balance, or they charge you at the end of the month. Okay? And sometimes like those fees are like $4. Even if you're off a penny, let's say that you had to have a minimum of $100, and your balance got down to $99.99. That penny could cost you $4.
What?
Yes. If you did not keep your minimum balance of $100, you thought you kept a minimum of $100, and you got down at $99.99, that fee could cost you $4 at the end of the month, that little penny. Gotta be careful with your balance. Number 5, rounded to the nearest 10th. Well, what digit is in the 10th place? Lane.
4.
And the 7 tells us to do what? Round up, so it becomes 3 5/10. Do we need to add zeros? No, because it doesn't hold any place value there. And number 6, we start out with 1,680 tulip bulbs. They're shipped in 35 boxes with equal number in the boxes. How many are in each box? 48 bulbs. 48 bulbs. Any questions, folks? Anybody have any questions for me?
Anybody? All right, so we understand the moving of the decimal point, is that correct?
Yeah.
Okay, good. So we're going to continue on with multiplying by decimals and a whole number. Okay. We're going to take a look on page 239, please. 239. Here we go. 239. On 239, as we take a look at that, we're going to take a look at being able to draw a picture of this and being able to show how we come up with groups of decimal values. We know how to draw decimal values in a 10 by 10 grid because we know each of those boxes represents how much? Each of those boxes represents how much? One what? Let me ask you this. How many boxes are in there? 100. So each one represents what? 100. 100. Okay? So, giant tortoises move very slowly. They can travel a distance of about 1,700 miles in 1 hour. How far could a giant tortoise move if it travels the same speed for 4 hours? I want you to have out 2 different colors of marking utensils. They can be 2 different colors of pencils. It can be a pencil and a pen. I don't care. It can be a regular pencil and another color pencil. It can be a pencil and a pen. I don't care how it is. Just so you have 2 different colors. Okay. All right, so here we go. So, we want to know how far he can go in 4 hours if he's only going 1,700 of a mile in 1 hour. Now, if you know anything about tortoises, they don't move very quickly.
No.
Okay? 4 hours, all right? So, we use our grid 10 by 10. We use our 10 by 10 grid. All right? We're trying to figure out how far it'll be in 4 hours. We want 4 groups of 1,700. Well, in one color, we're going to do 1 group. So there's 10, 11, 12, 13, 14, 15, 16, 1,700. We're going to change colors. And now we're going to do the second group of 1,700s. Does that make sense? There's 1, 2, 3, another 10, so that's 13, 14, 15, 16, 1,700s in the second color. So how many hours has the tortoise been moving? 2 hours so far, right? We go back to our first color, and we need another 17. 1, 2, 3, 4, 5, 6, and 10 more makes 16. and one more makes 1700. How long has the tortoise been moving along now? 3 hours. And we move back to our second color. We have 9, 10, 11, 12, 13, 14, 15, 16, 17 filled in. And how long has that Mr. Tortoise been gone? 4 hours. 4 hours. Okay? Does that make sense? So we've now done 4 groups of 1700s, right? And now we've done 4 times 1700s, right? Does that make sense? 4 groups of 1700s. So our product, well, we can figure that out here. 10, 20, 30, 40, 50, 60, right? 1, 2, 3, 4, 5, 6, 7, 8. And they are hundreds, right? Does that make sense? 6800s? Yes, no? So if we go back to our original question, are you guys all have this? If we go back to our original question, how far could the giant tortoise move if it travels at the same speed for 4 hours? It could get 6,800 a mile in 4 hours. That's a little over twice around the track out there in 4 hours. Okay? Not moving too far. Okay? Does that make sense, though? Does that make sense how to put it in the grid? Okay? All right. So as we take a look at our grids, do we have questions on the grids? Anybody? Anybody? Let's go up here to number 1 then on this page, 241. 5 times 600. 5 times 600. In 5 times 600, they've shaded in 5 different times 600, right? What is our total shaded in then? 300s? Look again. $30 is shaded in. If it were 300s, it would only be 3 little squares. 30/100s, or we could have said 3/10. Okay? Take a look at number 2. We want 2 groups of 3800s. How would we shade that in? Somebody get us started. We would do what? Okay, so 3 sticks. I'm going to make this bigger. There's some actual sticks. And what does that give us for a product? $76. Questions on that?
And I'd like you to try number 3, please.
Here's what that's at. And what was your final answer then? 9,600, yeah. Questions on how to fill these out? Anybody? What if you went over one whole box? What would you have to do?
Draw another one?
Yeah, use the second box. And then if this one was filled in and you started part of another one, it would be 1 and whatever part of the next one. Does that make sense? Does that make sense?
Oh.
Let's say that it was added to be 1 and 1,200. Does that make sense? Does that make sense? Questions on that? Okay. All right. I'm going to stop there for today. I want you to look in your books on page 243, please. If you don't still have grid paper, I know I gave out grid paper before. If you don't still have some, I do have more. If you still have some, just use it. You don't need to pick up a new sheet. Just make sure you number your problems. Does that make sense? Okay. So you're drawing pictures for these to come up with the answer. Drawing pictures to come up with the answer. But you're using your grid sheet. You're not creating your own grid sheet. Don't try to make a 10 by 10 grid. Use this. All right? Okay. Don't be a mess. We'll try doing it. Okay? You may cross off number 10. Yes.
Can we cut out the square and put it on the paper?
You don't have to. There's no reason to do that. And then 244. So 243, cross off number 10, and then 244. Okay? Tomorrow, your assessment questions, let me read off what those cover. I can't hear you. Okay, well, during study time, you can get one. I'm reading off a assessment topic right now. Multiplication of whole numbers. Any questions on that? Compare, add, and subtract decimals. Any questions on that? Patterns with decimals. Forms of numbers. Division. Is there a reason you are talking to your neighbor? Right at this moment, he needs a marker instead of listening. Any questions on any of those? Anybody need examples of any of those? Okay. Daily word this week. You're going to do one problem with your octagon partner. So please meet up with your octagon partner for about 5 minutes. One problem, make sure you mark which problem it is you're doing with your octagon partner. Yes. Who's your octagon partner? Jonathan. Who else is missing a partner? Okay, then you two are partners. Thank you.
Okay.
Make sure your masks are up and you're working with partners. All you're working on is one problem. Once you have that problem completed to your satisfaction, head back to your seat, work on your other things.
You. Oh. I Use a paradox to determine what the first and last names of the singular and these are like more bald more or brown. You do that. And as though I was going to put yes. George and the black boy were next door to each other. George Washington is George and the Boston boy lived next door.
Here, give me the pencil. Get up there and start this
All the other ones, the ones that we already have, yes.
Okay, you need to be working on that.
If there's a yes in the road, I should cross out.
Okay, once you have one problem done, go back to your seat. Reminder, once you have one problem done, head back to your own seat.
You can then X that first name in the last name.
Okay, I want everybody to stop
turn to the front side, which would have the 4 problems on it. Stop and turn to the front side, which has the 4 problems on it. Go to the very top of the page. That would be the top. You know, clear to the top, where there's that little band of blank white space. Get your first and last name up there. And now you may continue on.
This one's actually kind of easy. This one I don't understand. It's in the grade. You have to draw
I got mine. The bottom right.
Where's what?
So cute. I'm already this fun. did the rest of
Okay, if you're not back at your seat, let's get back to our seats and work on our assignment, please. Eli, get busy.
Tyler, you ran, get busy. Ellen, get busy.